Alright, so here we're going to do a video on a two-sample t-test looking at comparing reviews for the hot truck and Louis' lunch with these reviews coming from Yelp. Alright, so here let's just look at some descriptives for our two lovely vendors. Alright, so how many observations do we have? What's the min? What's the max? What's the average rating, and then again some function of the spread. So for the hot truck, all right, we have 40 reviews, and for Louis we have, how many do we have for Louis? All right, we have 31. Okay. The lowest of those reviews, I'm just going to simplify things here, A:A. Oops, got to put the equal sign in front of that. Here we go. All right, so now I can copy that over here easily. The max of the reviews, so A:A. All right, the average of those. And then the standard deviation of those. Getting really tricky here with my typing. Sorry, equals standard deviation of A:A. And let's just get rid of some of our decimals here. All right. So we see here that we have a few more reviews at the hot truck than Louis. The range of reviews is the same, 2 to 5 for each. But Louis is getting slightly higher average review at 4.32 versus 4.18. But as a function of this range, we see that there's quite a bit of spread across these reviews, that the standard deviation is almost a whole review. Right, so the question here is, for the population of reviewers for the Yelp population of reviewers for Louis and the hot truck, is 4.3 really different than 4.18? It's very skeptical because of the wide uncertainty in these values. Right? And so here we could form our null hypothesis, right, that average ratings are the same, right? So we're getting that basically we're saying here that mu hot truck equals mu, oops, sorry, Louis' lunch, right? And then our alternative here is that the average rating, right, it could be not the same, right, which would be a two-tailed test, or we could have average ratings. We could have, we could follow the average here, ratings, sorry, and say that, mu Louis' lunch is greater than mu hot truck, and that would be a one-tail test, right? And so here we're going to use so to calculate the p-value, right, we're going to use the ttest function in Excel, right? So it asks for the two data arrays, so we give it the hot truck. We give it the array that has Louis in it, right? So just grabbing those columns. And then it asks us for tails, a 1 or 2. For start off, let's do a one tail. And then the type, again, 1 for paired, 2 for unpaired, and equal variances, 3 for unpaired, and different variances across the two samples, right, aka the two populations. So given that our sample sizes are different sizes, we can't do a paired sample, And because we don't know if the same customer reviewed each of those, right? So we don't know that each row is from the same reviewer, then we have to do, right, we also can't do a paired sample, right? If we had 40 reviews for each and they were from the same reviewer, we could do a paired sample. Because we don't have that, we're going to do an unpaired test. And as a default, let's do unequal variances, which we'll almost always do, right? And here we see that the two-tailed p-value is 0.247. It's greater than 0.05. Therefore, we can't reject the null that the ratings are the same. We could do a two-tailed test, right? If we did a two-tailed test, t-test, again, we know that the two-tailed t-test is less specific, right? So we're going to be even less likely to generate a low p-value for this guy. We'll just do that for completeness sake. Do a two-tail, again, unequal variances, and it will be, yes, almost double the other guy, right around double, or in this case, exactly double. Pretty well. But again, it's less specific, so it has this higher p-value. So if we reject it under the one tail, we're always going to reject it under the two tail. All right, that sort of looks at our, completes our video here looking at the two sample t-test.